Welcome to the deep dive. This is where we take the sources you send us and we really try to pull out the key insights, the surprising bits, the stuff that matters without, getting lost in the weeds.
Exactly. And today we're diving into a really interesting research paper that came our way. WebThinker, empowering large reasoning models with deep research capability. It's a joint effort from Renmin University of China, BAI, and the Huawei Poisson Lab.
Some heavy hitters there, tackling what feels like a pretty core AI challenge. So our mission for this deep dive, let's really unpack this WebThinker framework. What is it? How does it actually work? And maybe most importantly, what could it mean, down the line? For AI, for research itself, we're going through the whole paper.
Yeah, what jumped out at me right away was the ambition here. They aren't just tweaking things, they're proposing a pretty fundamental shift in how AI can learn from the web actively.
Okay, let's get into it then. The paper starts by highlighting a key problem, right? With today's big AI models, the large reasoning models like, say, OpenAI's or DeepSeek's, what's the main limitation they're focused on?
Right. So the authors point out that while these LRMs are incredibly good at complex reasoning, solving problems step by step, they mostly rely on their internal knowledge, the stuff they were trained on. And that becomes a real bottleneck when a task needs really specific, up-to-the-minute info, or when it has to pull together knowledge from lots of different online places to build a proper research report. Their knowledge is vast, sure, but it's static, frozen in time, essentially.
So if they hit a question where the answer isn't in their training data, they're kind of stuck. They can't just effectively go look it up themselves.
Pretty much. And that's exactly where WebThinker enters the picture. The idea is to give these models the power to do deep research on their own, autonomously. So the AI can search the web, navigate around, actually click links and buttons, and even draft sections of a research report, all while it's reasoning through the problem.
Wow, okay. That sounds like a huge step. So it's not just passively retrieving facts, it's actively going out and investigating. How does WebThinker actually pull this off? What are the main innovations?
Well, they break it down into three key innovations. The first one is what they call the Deep Web Explorer.
Deep Web Explorer.
Okay. This is the part that lets the LRM dynamically search the internet, sift through results, click on links, and pull out the info it needs right when it realizes it has a knowledge gap.
So it's like giving the AI its own superpowered research assistant it can call on anytime. What makes this deep exploration different from, say, how AI uses search now?
The deep part is really about its iterative nature. It's not just one search query and done. The LRM can start a search, look at the results, and then maybe refine the search, or crucially, follow links on the pages it finds. It can really dig deeper, which is quite different from, standard retrieval augmented generation RAG methods.
Right, RAG. We've talked about that before.
Yeah.
So how is this different? Remind us quickly.
With typical RAG, it's often more of a linear process. You ask something, the system fetches some documents it thinks are relevant, and then the model uses those to answer. The retrieval is kind of a separate upfront step. Figure 2 in the paper shows this concept, that sort of fixed workflow.
Gotcha. And WebThinker?
With WebThinker and its Deep Web Explorer, the searching and exploring is woven directly into the reasoning process. It's not separate.
Oh, okay.
The AI decides during its thinking, okay, I need info on X, then goes and gets it, maybe follows a link, then continues reasoning. It's this dynamic loop shown conceptually in Figure 2, much more integrated.
That makes a lot more sense, actually. More like how a person might research something. Okay, so that's the Deep Web Explorer. What's the second big innovation?
The second is their autonomous think, search, and draft strategy. This builds right on the Explorer. It allows the LRM to juggle reasoning, finding information, and actually writing the research report kind of all at the same time.
So it doesn't do all the research then, right? It's doing both, like interleaved. That sounds way more organic. How does it manage that complexity?
They give the LRM 3 specific tools for this. First, a tool to draft content for different report sections. The model uses special tags like begin right section when it thinks it has enough info for, say, the intro or a specific chapter.
Okay.
Second, there's a tool to check the report's current status. It can ask, show me the outline, or show me what I've written so far, using tags like begin check article. Helps it stay organized.
Makes sense.
And third, an editing tool. Using begin edit article, it can go back and revise parts based on new information it finds, or just refining its thoughts.
It really is like having a built-in researcher, writer, and editor. Who does the actual typing based on these commands?
Good question. That's handled by what they call an assistant LLM. The main LRM is the orchestrator deciding what needs to be done. Search, write, check, edit. But the low-level text generation, the actual writing and editing, is done by this assistant model.
Clever division of labor.
Yeah.
Okay, so we have deep web exploration and this think, search, draft strategy. What's the third key piece?
The third is their RL-based training via online DPO. Basically, they use reinforcement learning, specifically a method called direct preference optimization, or DPO, to make the LRM better at using all these research tools.
Reinforcement learning. That's training by trial and error, essentially.
Yeah, right.
Rewarding good moves. How's that work here?
Exactly. They use RL to teach the LRM to make smarter choices about when to search, how to search, when to write, etc. They generate lots of possible ways the AI might tackle a problem, different reasoning paths involving the tools.
Right.
Then they compare these paths and create preference pairs, basically saying this path was better than that path.
And what makes one path better? What are they optimizing for?
According to the paper, it's based on three things. First, obviously, correctness. Did it get the right answer or produce a high-quality report? That's key.
Naturally.
Second, tool efficiency. If two paths got a good result, the one that used fewer tool calls, less searching, less editing is preferred. Be efficient.
Okay.
And third, thinking conciseness. If they're both correct and similarly efficient, the path with the more direct, less rambling reasoning process wins out.
Right. You want it accurate, but also efficient and, well, focused. Makes total sense. And the online DPO part. What does online mean here?
The online bit means the training is continuous and adaptive. They don't just train it once on a fixed data set of these preferences. Instead, the training data keeps getting updated based on how the LRM itself is performing and evolving. So the model is constantly learning from its own attempts, refining its research strategies over time. It's a continuous improvement loop.
So it's learning how to be a better researcher as it goes. Okay, the million-dollar question. Does it work? The paper goes into experimental validation. What did they actually find? Did it perform better?
They did quite a bit of testing, yeah. Two main areas. First, they threw it at some really tough, complex reasoning benchmark standard tests to see how well AI handles tricky problems needing multiple steps and outside knowledge.
Okay.
Second, they looked specifically at scientific report generation. Could it produce good, comprehensive research reports for open-ended questions?
Let's start with the reasoning benchmarks. Which ones did they use and what were the headlines?
They used some well-known hard ones. GPQA, that's PhD level science questions. GAIA, complex task needing info retrieval. WebWalker QA, which is specifically designed for needing that deep web navigation. And Humanities Last Exam, notoriously difficult multidisciplinary stuff.
So a tough crowd. And how did WebThinker do against other methods?
The results look, well, pretty significant. Across the board on these benchmarks, WebThinkers generally outperformed the existing methods they compared against, including standard RAG and other search-augmented models like Search-01. If you look at Figure 1 left in Tables 1 and 2 in the paper, the trend is quite clear. WebThinker showed some really solid gains.
Can you give us a feel for how big those gains were, like percentage-wise?
On some, like WebWalker QA and Humanities Last Exam, they reported improvements of, I think, over 20% compared to certain baselines. And what's really interesting is the performance of their RL trained version, the WebThinker 32B RL.
The one trained with that online DPO.
Exactly. On Humanities Last Exam, which is just brutal, it actually set a new state-of-the-art result for models around the 32 billion parameter size. And it even beat some larger proprietary models on that specific benchmark.
Wow. A 32B model beating bigger ones on that test. That's seriously impressive.
It really suggests the framework itself provides a powerful advantage, especially when fine-tuned with RL.
Okay, so a clear win on complex reasoning. What about the other evaluation area, generating scientific reports?
For that, they used a data set called GLAIVE, which has lots of general open-ended questions, perfect for testing research skills. They judge the reports based on things like completeness, thoroughness, factuality, and coherence.
And how did it fare there?
Very well, actually. Similar story to the reasoning tasks. WebThinker generally got the highest scores overall when compared to ARG baselines and even other advanced systems like one they compare to called Gemini Deep Research.
Okay.
Looking at Figure 1 right and Figure 4 left in the paper, WebThinker really shone in terms of completeness and thoroughness. It suggests it's doing a better job of gathering a wide range of relevant information and discussing it in depth.
The paper also mentions a visualization, a TSNE plot in Figure 4. What did that show?
Right, that's more of a qualitative insight. It plots the generated reports for different topics. The visualization suggested that WebThinker's reports on a given topic were kind of more spread out, covering a broader conceptual space.
Some more diverse perspectives.
That's the interpretation, yeah. That it's not just finding an answer, but exploring and synthesizing information from more angles, leading to potentially richer, more comprehensive reports compared to the other methods.
Interesting. So it seems pretty robust. Did they find it worked well with different underlying AI models, or was it tied to one specific type?
No, that's another key point they make. They showed it works across different sizes of the DeepSeek R1 model, 7 billion, 14 billion, and 32 billion parameters. Figure 5 shows this.
Right.
In their tests, adding WebThinker consistently boosted performance compared to the base model using just its internal knowledge or standard R, regardless of the model size. So the framework seems quite adaptable.
Good to know. And they also did ablation studies, right? Taking parts away to see what happened. What did those show?
Yes, Table 3 covers the ablations. They basically confirmed that all the main components are important. Removing the Deep Web Explorer entirely caused a big performance hit everywhere, reasoning and report writing.
So the active search is critical.
Absolutely. And even within the Explorer, turning off the ability to click links also hurt performance, showing that shallow search isn't enough. You need that deeper navigation.
Makes sense.
For report generation, taking away the autonomous drafting part, the interleaving of writing and researching, caused the biggest drop in quality. And removing a check and edit tools also made the reports worse, especially less coherent.
So it really is the combination of all three. The deep exploration, the autonomous drafting strategy, and the RL training that makes WebThinker work so well.
Okay, as we sort of wrap up the paper itself, what do the authors see as the bigger picture, the broader implications?
Well, they're quite optimistic. They position WebThinker as a major step towards AI that can handle really complex, knowledge-heavy tasks in fields like finance, science, engineering, basically anywhere deep research is needed. Yeah.
By enabling AI to learn and find information from the web so effectively and autonomously, they think it could make AI much more reliable and useful in the real world. You could imagine AI doing things like conducting literature reviews, spotting research gaps, maybe even helping design experiments.
That's a pretty transformative potential. Did they mention what's next? Future research directions?
They did. They have plans to extend it to handle multimodal information, images, video, not just text. Also exploring more advanced ways for it to learn how to use tools, maybe even add new tools itself. And interestingly, investigating GUI-based web exploration so it could interact with more complex websites, not just static pages.
Wow. Okay. So this really does feel like a significant development. To sum up our dive here, WebThinker seems to be this really clever way of embedding deep research skills right into the AI's thinking process. It's not just fetching data. It's actively exploring, learning, synthesizing, almost like a human researcher, but potentially much faster and broader. That's kind of the aha moment for me.
I agree. And stepping back, you can see how this could really democratize access to deep knowledge, couldn't it? Potentially speeding up discovery across many fields. But of course, it also brings up some big questions, you know?
Like what?
Well, how does this change the role of human researchers? And critically, how do we ensure we can trust the complex reports and conclusions these AI agents generate? Those are things we'll definitely need to grapple with.
Absolutely. Crucial points. And for you listening, maybe think about how a system like WebThinker could impact your own work, your own interests. How might an autonomous research agent change how you find information, or even the kind of questions you could tackle? Definitely food for thought.
And if you want to read the source yourself, the paper is WebThinker, empowering large reasoning models with deep research capability. You should be able to find it easily with a search. Like et al. Are the authors.
Great. Well, thanks for joining us on this deep dive. If you come across other research or sources you think warrant this kind of exploration, definitely send them our way. We love digging into this stuff with you.
Yeah. Thanks for listening. We'll catch you on the next deep dive.